This conference will now be recorded.
That's good.
Good evening, everyone. I'll join and
Good
then start
evening.
into natural language processing. Those who are not speaking, I'm advising you all to mute. As an introduction to natural language processing, the agenda for the class is what I said here is what is NLP? Why do we use NLP? What are its capabilities in human life? And there are two components which we mainly focus on, and some history on NLP, when did it start and from where we are supposed to drive the components, some of the NLP definitions and the different levels of natural language processing, and the applications of natural language processing, and then we'll move on to simple pre-processing techniques by hands-on. Then to compare the different NLP processing techniques when we do similarity measures. Then advanced level topics like topic modeling, then the machine learning technique also we would deal with. Hope my voice is audible to everyone. What is NLP? It's a branch of AI. It deals with interaction between the computers and the human. So as you all know, human-computer interaction is also starting with the basic knowledge of natural language processing. So what is the objective of natural language processing? The objective here is to read the language, to decipher, understand, and make sense of the human languages in a manner that is valuable to the human. So mostly all the NLP techniques rely on machine learning techniques, which allow us to derive meaning from human languages. Because the way how we speak and the different kind of annotations what we use, the inner semantic level of the language what we use is totally different how a human can interpret the information. So for making the computers to understand what a human thinks about the natural language and how to make the others to understand the same language what I have spoken, we use natural language processing. So it's a branch of AI. So we might be using a lot of heuristic approaches also in natural language processing. And NLP used for some of the real life applications. Some applications I have just mentioned here. They are Google Translate, word process, as we are currently using. Even Gmail has a Grammarly inbuilt bot also with a technique of natural language processing. And you can do interactive voice response, maybe the Siri, Cortana, and other interactive voice responses. And some of the personal assistant what we use also is an example of natural language processing. So these applications will allow us to mention what we are trying to say to the computers, and the way we could also get the results, the way what the other human would speak to us. So the same language would be processed using natural language processing. And some of the natural language processing capabilities includes the left side things are all the capabilities, and the right side things are all the list of things what we could do out of these capabilities. It's the first capability called content categorization, in which we could do document summarization. Let's say a lot of documents like movie reviews are there, or sports review, or a general election campaign reviews are there, where I would like to create a summary out of that. We would go under the capability of content categorization. We first would like to know what type of content is there in the document, and then we would be categorizing them into different topics. Then we will generate a lot of summaries out of those contents. This is called content categorization. And if you look at the second capability called topic discovery and modeling, wherein we will identify the contents and then we generate a topic out of the contents. So if the news is already displayed in a page, let's say Times News, wherein there will be a lot of news in it. But by reading the words of each news, we could categorize them, or we could develop a topic out of it. That's called topic discovery. So it could be applicable for any kind of documents wherein the documents are present in multi pages, but I would like to give a summarize out of those multiple pages. Topic discovery and modeling help us to do such kind of things. Next thing is contextual extraction, wherein we automatically pull text-based sources. So here it is going to identify the word level semantic in which the context is built. Maybe the word, what I have spoken, the word what others would spoken is totally different. So the in which way it is spoken is what contextual deals with. Then sentiment identifies the mood or subjective options with large amounts of text. It includes average sentiment, maybe a positive or a negative or a neutral analysis we could generate. So these sentiment analysis could be applied on most of the social media, social network applications. We could understand the people feeling about a particular tag or an interesting about a subject. We could generate out of this sentiment analysis. The next capability called speech to text and text to speech conversion, which we could maybe we are familiar with this task because some time back also we were doing the same task, converting them into speech or speech to text also was happening. Next thing is document summarization and content categorization is one and the same. So I'm not going to talk about that. The last one, it is kind of automatic translation of text or speech from one language to another. Maybe the Google Translate is one such example, wherein in a foreign land, if you do not know a language, what is written on the signboard, we can just take a pic and then allow the Google Translate to translate to our natural language or the language we want. So this kind of machine translation could be done using the last application. When we talk about natural language processing, there are two main components involved in it. One is natural language understanding, the other one is natural language generation. If you look at it, natural language understanding is quite easy for us to do tasks than natural language generation, because natural language understanding is something like we are making the computers to understand the language what we wrote or speak, but it is in return it's very tough to generate a language by the system. So to get a better understanding about natural language understanding, I just gave small points here. Deriving meaningful information from the natural language. Imagine a concept space wherein we would be representing these concepts into a vector model. If you look at that right hand side, that is a vector space model given there. And here, any idea or a word or a concept has a unique meaning in it. So those meanings we would be representing them as a vector value into the model, and usually via a vector space. So NLU mapping the language into this kind of vector space model. So if you look at that, the model what here used here is like this is the one. Maybe the vector space models we could see that if we see that natural language generation, what we do is like after understanding the language or after making the computer to understand the language, we will allow the computer to represent an answer for the language of what it is understood. So it is opposite to NLU. So it is quite tough for us to generate a conceptual way of representing the language to the user. And if you look at natural language processing, wherein speech versus text, both you could apply, because it is not only the written components, it can also process voice information too. So natural language can refer both text as well as speech. Goal of both the processing is going to be same in terms of NLU as well as NLG. So history of NLP, it's not at all new to the human being. It was there for maybe 3 eras, which is mentioned in 1950s to 80s, wherein people started developing linguistic methods, and there were handwritten rules. So here, natural language, as I mentioned, the language which is universally accepted by all over the world is English. So that's what the linguistic methods and handwritten rules were developed in the year of 1950s to 80s. And 80s, there is a new dictionary, we call it as corpus, which was universally accepted, as well as there were a lot of statistical methods started using on developing models to process natural language in a better way. Now we are moving to deep learning, wherein a lot of contextual information are brought into existence using deep learning methods. Maybe CNN, RNN could be of more used when we process complex sentences. So it is not at all new to the human being. So NLP consists of these five as the main component. They are phonemes, morphemes, syntax, semantics, and discourse. If you look at phoneme, the smallest sound unit in a language, the way how are we supposed to pronounce it, or the way how are we to write it is what phoneme describe about. Morpheme is nothing but the smallest unit of the meaning in a language. Let's say if a word represented in a sentence maybe consists one meaning in that paragraph, maybe in other paragraph it would represent something else. That way morpheme gets changed. And third important component called syntax. Syntax, as we all know, how are we supposed to write the set of words? How are we supposed to mention the set of sentences? So there will be a specific grammar as well as the way how we write the syntax also. It is totally depends on the language. Semantic is uh, inner meaning or inner level of understanding the language is called semantic. Discourse is one such important component in NLP, wherein if we write complex sentences and if we mention a sentence, maybe with an example, I'll say here, in a corner, maybe corner house ice cream, if I say. The corner house ice cream, the corner house is representing one subject, wherein if in the second sentence, I am representing the corner house as it. But if I'm dividing these two sentences in a two different way, that it represents the subject which was present in the previous sentence. So if we are not processing this complex sentence together, the discourse will be not understood by the computers. So wherein we lose the context, what it means. So that's how the conversation and persuasive writing would be continued or followed using discourse integration. Maybe when we see some of the examples, I'll better explain what is discourse analysis. So if you look at levels of NLP, how the process goes on is, so if we look at here, morphemes and phonemes both are targeting. Morpheme, if you look at it, is going to allow to process the text. So when we are processing the natural language by means of text, we look at the morphemes. When we are going to process the natural language processing in the mean of speech, we look at phoneme. Phoneme maybe we might have learned in English, so the same could be followed here also. So after these two, we would develop a syntax out of the words what was spoken in morpheme and phoneme. Then using that syntax, we will refer the corpus what is available on the whole in the internet. Those corpus methods will allow us to derive the inner meaning or the semantic from the language what was spoken. Then after which we could maybe here we can apply all the machine learning or deep learning methods to identify or derive the better discourse analysis out of the complex sentences. This is just an example. It's given how levels of NLP is carried out in the natural language processing. And some of the real-time applications, maybe those who are doing research also can pick up some problems out of these applications. What is mentioned, one is ML, machine learning on text. Maybe you could use it for classification or regression tasks, as well as you can go for clustering also. So clustering mainly focus or it could be allowing the user to develop topics out of doing clustering different words. Then document recommendation, maybe it's popular when you read a certain books online, maybe in Amazon Kindle or in Amazon website. If you read online and it could suggest you some of the documents, whatever the text which has inside in the previous book what you read, maybe it could be recommended by the technique what was available. The next thing is language identification. Maybe if the language is written or spoken, what language is that you could understand, or you can build a system to identify what language is that. Next thing is natural language search. Maybe the language what I am looking for using Google Translate, this could also be an example for that. Next, one such example is called sentiment analysis. If a particular market search is done or market analysis is done, we could understand that how the product is moving among the audience, how the sentiment towards the product, if it could be identified by the way people are commenting or writing reviews about the product, or you could even find out how the product is popular in the market. So these could be analyzed using sentiment analysis based on the text what is available in the reviews and how the people have been tweeted or mentioned in their posts. According to that, the sentiment analysis could be done. Text summarization, as I have already told you, maybe if multiple documents or single document, a larger text is available, wherein I would like to precisely give a summary out of multiple documents or single document, you can use multi-document summarization or a single document summarization technique to summarize or to give a precise summary out of the available text. Next thing is extracting word or document meaning. There are a lot of methods. One popular method what we are using is vector space model, wherein each word we use a count of its how many times it's appearing on the given text. So depends on the frequency value, the vectors are going to be formed. So this method, while doing pre-processing technique, we will maybe I would explain you in detail how we would extract the word from the document and what is it, the meaning of it, and how many times it is appearing depends on that. It will be represented into a vector space model. Then relationship extraction is nothing but what I have told you on discourse integration, wherein maybe if complex sentences are spoken, you found a full stop maybe after 4 or 5 lines. I would like to interpret a relationship between the complex sentences, what is written, can also be developed using natural language understanding. Then the last application, what was mentioned as topic modeling, maybe a lot of text present, wherein I would like to classify news into sport, or I would like to classify them into a famous reality show, and some of the news what is processed about maybe a product review. Like that, I can define a topic discovery, or I can just build a topic out of the set of news available. So these are all some of the natural language understanding applications. This is something which is quite easy for a user. But on the other side, if you look at it, NLG applications, it's quite tough for us. Maybe after processing the complete document or after processing the complete text, what is available, the computers need to develop or just give an answer back to the human. So you imagine that how much or what type of answer do you expect from a computer is what expected from this NLG applications. Image captioning is nothing but, let's say a image, maybe an outdoor image is given, outdoor beach image, let's imagine. So I would like to assign a image caption for this. What the computer should do. When you are going to represent the image into machine, you would need to extract some of the features out of the image. Let's say these features are like the color, texture, or shape, whatever available in the image. As a human being, when we see that outdoor beach image, we could classify the list of objects available in that image. Let's say those objects are like trees, maybe sea, and the sand, and the sky. So it depends on the color code, we could understand what all the objects are present in the image. So as a high level perception, as a human being, we could say these objects are this. But the computers cannot understand what these objects are. It is going to understand them as zeros and ones. So it need to understand better and then assign caption for that image as a human being. Like outdoor beach image, it has to say that image caption. So you just imagine that how tough it is for the system. Though there are better libraries for extracting low-level features of image, the natural language generation is quite tough for the system. And then text summarization in a better way also you could do using natural language generation. Machine translation, maybe after we speak, the similar way, whatever we expect from other human being, we are expecting it from the system is what machine translation does. Question answering and what all the chatbots available, so much more applications you can think about on natural language generation. So for doing NLG, NLU is most prerequisite. So we would like to cover up all the prerequisite things in this classes. One more small example which I would like to say, that is email filter. Depends on the words, what is available in the spam email, we are saying or classifying them into an inbox or a spam. And this is called image captioning. If you look at the image caption, what was given down, man in black shirt is playing guitar. This is a sentence. So man in black shirt is totally representing the object, who's maybe the man who's sitting with the black shirt. And the other object, what it found is the musical instrument, guitar. And then the verb phrase, which is connecting between the subject and the noun, is what is represented. So we will study these things in detail in the further classes. I would like to pause here for a few seconds to ask whether the flow is okay or not.
That's fine.
Okay, NLP in simple example. Set of words, maybe what is text, if we know that most of us would be doing text mining tasks. Set of words sequentially written is what we call it as text, and each word in the text has a meaning, where the text may or may not have a meaning in it. In the machine learning, we take features, isn't it? So before processing the data, we would request or we would analyze the set of features we would like to process. Similar way, if a set of words are already given as a text, we just need to extract some of the important features for further analysis. So right hand side, there is an example done for you, like text is given as I love programming. Maybe the individual words are called as features here. So I love programming are the set of features for the text processing. The simple text is given like this. How do we derive the features? So we call a process called tokenization. Tokenization does the job of deriving the features out of the text. So a text is divided into tokens. Open source tools like NLTK, Natural Language Toolkit, help us to derive the tokens from the given text. So in Python, we would be doing this maybe in the next hands-on session. We would do how a feature could be extracted using tokenization in Python. Let's say we have an example here. I love programming. I am using word tokenize. See, NLTK is the library what I'm supposed to use. Tokenize is a module from which I am using word tokenize is the module. Why word tokenize? Why can't something else? See, there are two types which I have used. One is word tokenize, the other one is sentence tokenize. If I would like to process each word as an individual feature, I am supposed to use word tokenize. If I'm going to use the whole sentence, maybe from the full stop, I would like to extract sentence by sentence. So wherein you can go for sentence tokenization also. So there is two ways to do tokenization. One is either word wise or a sentence wise. Even paragraph wise is also available, but which I have not used. I have used only word and sentence tokenization. So in, let's say we have an example done here. Maybe the example goes like this. I love programming and programming also loves me. Word tokenize of the given text is given. So individual words are all extracted out of this called tokenization. And what is lemmatization? See, if a particular word is repeated twice, maybe the token could be considering each repeated word as an individual token. So it's a tedious process to understand how many times the same word is appeared in the vector space model. So we have a special process called lemmatization, wherein we could eliminate such repeated words out of the tokenization. we would like to process individual unique tokens from the text given. As a pre-processing step, lemmatization allows us to eliminate all the repeated words. So we have in the previous slide when I was showing you, maybe the programming is repeated twice, wherein all other words are all unique features. So I would like to take only one programming out of this. I use lemmatization as a process to eliminate programming. So other than that, I love programming and also loves me are all individual tokens. So if you look at the love, if you look at in this sentence, what is output shown here, love as well as loves, both are meaning the same. The loves is derived or a simple present tense sentence of simple present of love. So these kind of form, the same sentence is repeated with the inflectional form is called inflectional forms. We need to remove these and consider this love is also be a single token. So for that, we will be removing these inflectional endings as also lemmatization. One is repetitive words, other one is inflectional form of this also could be done. And if you see that lemmatization, lemmatizer, there are many. WordNet lemmatizer is one such lemmatizer wherein individual words are going to be considered and their inflectional forms are going to be removed. So when I do hands-on session, I would explain in detail about the lemmatizer. From the stem is what a module on the NLTK library. So from that, WordNet lemmatizer is what we are taking into consideration to have unique words without inflectional forms. Next process in the pre-processing is stemming. The word programming is similar to the word program. This is also a kind of inflectional form, wherein it is derived from the word called program. So finally, the features are I love program and also me. If you look at the word stem, how it looks like, it is giving a normal idea about weight. Weight can be represented in a different inflectional forms like weighted, weights, and weighting. This is a word stem. And again, one more stemmer is also there, wherein Porter's stemmer. In the next class, when we deal with stemmer, I'll list out all the stemmer types and what it is. Why do we use it also? We will see that in the next class. And what is stop words? See, some of the words wherein we don't process, which will not have much meaning when you do vector space model processing. See, there are some of the words which occur very frequently. Let's say I, we, I, do, does. See, some of the stop words which is represented. It is what is stop words and how do I understand that? We don't need to worry about what all the stop words are available in English. It's already kept readily for us in the corpus. If you call out the corpus module from NLTK library, it will allow us to show all the stop words which is in English language. Similar way, there are other languages also. We can refer what are the stop words for different languages. So if you see that stop words of the English, I just printed here some of them. So these are all stop words wherein we don't need to process it because individual words which gives us a unique meaning for the context what we speak is what we need to understand as features. Those features are extracted and then processed in NLP, not all. So some of the unwanted things like stop words would be eliminated using stop word removal technique. So that is discussed here. So we convert these text into lowercase. Maybe you could do some of the other text processing also to avoid or to understand the text better way. Now, what is the vectorization or how do we represent a feature vector model? Now the data set, maybe I'm taking a small data set called 1 and 2 with the sentence I love programming. The second sentence is programming also loves me. So after some of the normalization technique, lemmatization and stop word removal, the final features what I am considering out of this is love programming also, because I would be removed as a stop word. Love programming is going to be considered. Now programming is also repeating in the second sentence. So I'm not going to take that again as an individual feature. The feature is already there. So love programming also, all the three are considered as final features for representing this two data set. So the final set or the feature vector finally we arrive here is love programming also. This we call it as lexicon or dictionary. Why lexicon or dictionary here in NLP? See, when we try to learn a new language, we would follow a set of sentences from a universally accepted dictionary or lexicon. So if we refer that lexicon and dictionary, that would become the model for us to follow or write the further sentences. Similar way, for deriving some of the implicit meaning out of this, we would follow this as our lexicon. If we cannot feed the words to the model or maybe in ML algorithm, the feature values must be in numbers. So we cannot process this as it is directly to any ML model or any algorithm. So we take the count of every word in every document as a value. That value become the feature vector value. So if we see in the next slide, how the feature vector is represented. The process of representing the text into vectors as numbers called document vectorization or word vectorization. Example, I love programming or love programming here. After changing this, we feed it as 110 as a vector. Let's say the word what all we have in the final features is represented in the first sentence. So the word, there are two words represented. Maybe if you look at the first sentence, love and programming, if you look at here, maybe this one consists of love as well as programming. So for these two, one is represented. It does not have also. So the first feature vector of the data set would be like 1, 1 and then 0. This 0 represents the final feature also is not present in the first sentence. But if you look at the second sentence, programming is present, love is present, and also is also present. So the feature vector for the second data set is going to be all ones like this. So that's what represented in the next slide as 110 and then 111. So this is called document vectorization. Now it's a kind of matrix values wherein we can process it easily using ML algorithms. So what are all the tools we require when we do hands-on in the next class onwards? I just mentioned here, if you wish to use any other IDE also, it's possible you could use it. So I was using Anaconda Navigator because it's a community space wherein many of us would work collaboratively. And the IDE what I have chosen here is Spider. Maybe many of you would have already used Jupyter Notebook. That is also available in Anaconda Navigator. And here, some of the toolkits which is most popular we would be using in further process called NLTK. Text blob where it wraps around NLTK and make it as easier to use. Spassy, it is built in on Python, so it's fast and powerful to do NLP tasks. And Gensim, wherein it's great for topic modeling and document similarity too. And regular expression, maybe I would like to continue in the next class because it need to be taught as a separate session. Maybe if you have any idea about regular expressions, we could have a discussion in a separate session. I would stop here so that we can have a question answer session kind up to whatever is. See, till now I had given a general introduction about NLP applications, what are its components, what NLP capabilities are. With the use of NLP capabilities, what all applications we could build, and then where it is most popularly used, and some of the pre-processing techniques, what we are going to do out of the text is what discussed. Regular expression is again we could find patterns using regular expressions. Maybe if it is already done in Python, we would eliminate this. Okay, someone is asking again, explain document vectorization part. Okay, let me explain that. There are two. If you look at the final features out of this lexicon, what is given here is this. The first feature is love, programming also. Depends on this final feature only, we are going to represent this data set. If you look at here, we have the feature love which is present in 1. So we would be giving the feature vector for the sentence 1 as 1. This 1 indicates love that is present in the first sentence. And if you look at this programming is also present in the first sentence. So again would be given as 1. If you look at also, that's a final vector which is not present in the first data set. So it could be represented as 0 here. Again, if you look at the second data set, all the three like love, programming also. You can ask me a question. It is not love directly. It has an inflectional form called loves. That is also acceptable because the loves could be eliminated using word stemmer. So that we can do it and then represent love as a feature vector. So if you look at love programming also, all the three are present in second data set. See, if you look at the first data set, even I is going to be eliminated as a stop word. So this is going to be a stop word, and even me is going to be a stop word. We will be eliminating it. This is just a raw data I have shown you. So love programming alone will be there in the first data set. Programming also love will be there in the second data set. So then the feature vectorization table looks like this 110 and 111. That's what mentioned in the next slide if you look at it.
Yeah, Ambika, why we are creating a document vectorization table?
Come
So I
again.
think so. Why we are using this table, vector, the document vectorization
Okay.
table?
Okay. See, when we feed the data before ML model, we would need to use this vector table only to process. We do not use words as it is for processing. We would be using this document vector as the data for the model construction. Any other questions regarding this vector model? Let's say feature vector is already defined like in the previous slide if you say love programming also. Okay, so I would like to understand which document contribute towards the final vector most. You see that all ones in the second document representing, that's the document representing the final feature most, correct? 100%. But the first document is maybe up to only some percentage is less because also is not present in the first vector. So this is how depends on the document vectorization or this vector table only being further used for constructing a model. And in email spam filtering, if you take as an example, the words what are all contributing towards spam, maybe some of the words we consider that if these words are all present in our mail, those mails need to be considered as spam. So those words can be converted into a vector table, and then the final features of the good mails which need to go to inbox, those as a feature vector could be considered. And you can consider those feature vectors in this vector. If that is not present, those mails are moved to spam. That way it works out. Any more doubts you can ask on the document vectorization. This is just a simple example which I have chosen to explain. Maybe when we move into further ML model construction, you would see why and how these numbers are taken into consideration for further processing. I have for you a set of text mining assignment tasks also. If anybody willing to, I can share it in WhatsApp. Any other doubts or we can close this session today? Thank you for everyone to joining. And maybe in the next class, if anybody wish to listen to regular expressions, maybe if you have missed in Python classes, we can see that, or else we can directly proceed with the pre-processing techniques directly as well. Thank you everyone for
Pankita,
joining
you
the
would be
session.
sharing
Come again.
the explaining assignment you would be sharing right now.
Yeah, if you wish me to, no, after pre-processing, I'll share it because that has all pre-processing tasks.
Okay.
Small assignments like this, converting them, removing stop words, pre-processing, stemma example, lemmatization example, tokenization example. Those things I have as a simple example. So I could share that after the tomorrow's class maybe.
Sure.
If any comments, I would like you all to post it in the group so that I can improve myself. Thank you so much for everyone to join this class.
Thank you.
Thank you.
Thank you, Amrita.
Thank you.
Bye-bye.
Thank you.